Module 8, Infrastructure Maintenance, Sustainability, and Lifecycle Management. 1. Conceptual understanding of infrastructure. Lifecycle management. Infrastructure lifecycle management involves a holistic approach encompassing planning, assessing expected lifespan, maintenance requirements, and sustainability considerations at the design stage, construction and commissioning, implementing standards, quality assurance, and proper documentation for future reference. Operation, efficient utilization of infrastructure, monitoring performance, and minimizing downtime. Maintenance, routine, preventive, and corrective interventions to preserve functionality and safety. Decommissioning or upgrading, end-of-life management, repurposing, or upgrading to meet evolving societal and technological needs. Lifecycle management integrates engineering, financial planning, environmental management, and governance, ensuring that infrastructure remains an asset rather than a liability. 2. Types of infrastructure maintenance. Effective maintenance strategies are critical for prolonging the life and performance of infrastructure. A. Routine maintenance, daily or periodic inspections, cleaning, minor repairs. Examples: road surface patching, cleaning drainage systems, repainting bridges. B. Preventive maintenance, planned interventions based on anticipated wear and tear to prevent failures. Examples: scheduled servicing of power transformers, periodic resurfacing of highways. C. Corrective maintenance, unplanned repairs following failure or breakdown. Examples: fixing a burst water pipeline, repairing collapsed sections of a bridge. D. Predictive maintenance, use of modern technology and data analytics to predict failures before they occur. Examples: sensor-based monitoring for vibrations in bridges, AI-powered predictive modeling for road deterioration. 3. Financial sustainability of maintenance budget. Allocation: governments must set aside adequate funds for ongoing maintenance, not just construction. Maintenance trust funds, dedicated infrastructure funds that ensure consistent financial resources. Public-private partnerships, PPPs. Concession agreements often include maintenance obligations for private operators. Cost-benefit analysis. Investing in preventive maintenance reduces long-term repair costs and extends asset lifespan. Fact: studies show that investing $1 in preventive maintenance can save $4 to $6 in corrective repairs over an asset's life cycle. 4. Environmental sustainability and infrastructure. Sustainability requires integrating eco-friendly practices and climate resilience into infrastructure management. Green building practices, energy-efficient designs, low-carbon construction materials, and water recycling systems. Climate-resilient infrastructure, roads, bridges, and dams designed to withstand floods, storms, and temperature extremes. Circular economy, principles, repurposing construction waste, recycling materials, and reducing environmental footprint. Sustainable urban infrastructure, incorporating green spaces, efficient public transport, and renewable energy systems. Sustainable infrastructure ensures long-term functionality, social acceptability, and environmental stewardship. 5. Institutional and governance mechanisms. Lifecycle management requires strong institutions and governance frameworks. Regulatory oversight. Agencies monitor quality standards, compliance with maintenance schedules, and safety protocols. Asset management units. Centralized units that track infrastructure performance, budget allocations, and lifecycle interventions. Transparency and accountability. Digital reporting and e-governance platforms reduce corruption and ensure proper use of maintenance funds. Stakeholder engagement. Inclusion of local communities and private partners in maintenance planning improves effectiveness and social acceptance. 6. Technology-driven infrastructure management. Modern infrastructure maintenance increasingly relies on technological innovation, Internet of Things, IoT. Sensors embedded in roads, bridges, and buildings monitor structural health in real time. Geospatial information systems, GIS, mapping and tracking infrastructure assets for effective monitoring. Predictive analytics and AI, forecasting wear and tear, scheduling maintenance, and optimizing resource allocation. Digital twins, virtual replicas of infrastructure assets for monitoring performance and simulating stress scenarios. 7. Challenges in maintenance and sustainability. Underfunding. many countries prioritize new construction over maintenance, leading to asset decay. Institutional weaknesses, poor coordination, lack of trained personnel, and overlapping mandates impede effective lifecycle management. Corruption and mismanagement. Funds allocated for maintenance may be misappropriated, reducing project effectiveness. Climate risks. Aging infrastructure is increasingly vulnerable to natural disasters and changing environmental conditions. Rapid urbanization. Expanding cities strain existing infrastructure, requiring continuous upgrading and maintenance. 8. Best practices. Singapore. Rigorous asset management frameworks and preventive maintenance ensure longevity of urban infrastructure. Germany. Life cycle cost analysis integrated into infrastructure planning and budgeting. Rwanda. Use of GIS and digital tools to monitor road conditions and prioritize repairs. Norway. Integration of sustainability and resilience into infrastructure design, ensuring low environmental impact. These best practices highlight the importance of combining technical, financial, and institutional mechanisms for sustainable infrastructure. 9. Policy recommendations. Allocate dedicated budgets for maintenance alongside new construction projects. Implement preventive and predictive maintenance strategies using modern technology. Institutionalize asset management systems for systematic monitoring and reporting. Incorporate climate resilience and green principles into all infrastructure projects. Promote public-private collaboration for lifecycle management. Enhance capacity-building programs for engineers, managers, and policymakers in infrastructure sustainability.